I'm welcoming the first author here for the paper, WriArm, leveraging wrist movement to design Wrist+Arm based teleportation in VR. This is a ISMAR conference paper, and I welcome Sohan Chowdhury. It's a paper from Sohan Chowdhury, Amanat Ullah, Nathan Bruce Pelmore, Purang Irani, and Kalan Hassan. And the speaker is the PhD student, Sohan Chowdhury. Please go to the stage.
Hello, everyone. I'm happy to be here presenting WriArm, leveraging wrist movement to design wrist and arm-based teleportation in VR. Just one correction, I'm a master student, but yeah, that's fine. Virtual reality users use locomotion techniques to move through the virtual environment. Teleportation is a widely used locomotion technique for VR. Users mostly use controllers to point toward their destination and use controller buttons to perform various teleportation actions. However, researchers have shown that holding a physical controller in your hand, that kind of limits natural and immersive interactions and makes the overall experience somewhat less intuitive. So, sorry about that. I'm having a little bit of a technical issue, I'm sorry. Okay, so modern VR devices with improved hand tracking enables users to perform VR interactions without needing a controller. Researchers have previously shown that hand-based teleportation techniques are there like for teleportation, but there are some limitations. For example, they've been using only arm-based pointing and not considering height traversals in teleportation, only using flat terrain, and then using timeouts or dwell to perform the teleportation instead of using gestures. So, we present WriArm, a novel controller-based, hand-based implementation for a complete teleportation system in VR. First, we present an arm and wrist-based implementation for teleportation pointing in VR that allows fast navigation for truly 3D environments. And to our best knowledge, we are the first to propose a set of gestures that can be used as an alternative to controllers for teleportation sub-activities. What that is, I'll talk later. And thirdly, we present our findings in the performance evaluations of the system in conditions where targets are placed in more realistic positions, varying in distance, elevation, and angles in combination. So in WriArm, broad arm movements are used for moving the parabola rapidly, and the wrist is used for finer control over the angles of the parabola. Wrist flexion and extension in combination with arm vertical angle is used for changing the launch angle of the parabola, and radian and ulnar deviation in combination with arm lateral movement is used for left to right movements. Here you can see that a user is leveraging their wrist movement to change the angle at which the parabola is launched, along with their arm movement. This attempts to provide more control, especially when navigating through elevation changes and also in flat navigation conditions as well. We also propose a set of gestures that can be used as an alternative to controllers for teleportation sub-activities. We identify 4 sub-activities: activation, pointing, confirmation, and cancellation. During any general hand interactions, the user can perform the activation gesture at any time to enable the teleportation parabola. When the parabola is active, they use the pointing gesture or posture to move the parabola to where they want to go. And finally, they use the confirmation gesture to be teleported to the destination. Finally, the user also has the option to use a cancellation gesture at any time to get rid of the parabola and return to normal hand interactions. Here's a short demonstration. First, we have activation. Then we have pointing. We have confirmation. And finally, we have cancellation. Before moving on further, I want to talk about some relevant work. One of the most strongly related works is Point and Teleport by Bozgaitley and colleagues, where they allowed users to simply point to where they want to go and be in the virtual world using their hands. But they were using a timeout for doing this, and they were not considering elevation changes. And you have to hold the position stable for 2 seconds to be teleported. And so, I'm sorry about this. I keep having a little bit of technical problems, but OK. So And in another work called Controlling Teleportation, Schaefer and colleagues compared one-handed and two-handed teleportation techniques for teleportation and concluded that one-handed techniques had a lower task completion time. From this, we decided to limit our work to one-handed techniques instead of two-handed. And in a recent work, Skyport, which explored controller-based teleportation, so the previous two works I mentioned actually work with hand-based teleportation, but this one is controller-based. But here, the researchers actually explored traveling to different heights using teleportation, and they posited that height changes, elevation changes, should be explored more extensively. Although in their task, they were using only height change or only distance changes, but taking inspiration from this work, in our hand-based work, we decided to include the combination of both height changes and distances for a task design. So first, we wanted to find suitable gestures for the 4 teleportation sub-activities, which we're going to call a gesture set. Each set would have 4 gestures for each action needed in a complete teleportation system. So 1 gesture for activation, 1 for pointing, and so on. But as there are many gestures possible for each action, we performed a design study. 8 graduate students with AR/VR design experience, each produced several gesture sets with many different gestures. Each set contained a gesture for each of the 4 sub-activities. Then, 2 researchers analyzed all the produced gesture sets and chose 5 from them. The selection criteria for choosing the 5 was based on a few factors: the number of times a specific gesture were repeated by designers for the same action, cohesiveness, or how one gesture flowed into the other, and also the technical feasibility or the hardware limitations. Then we sent these 5 gesture sets that were picked back to the designers, and then from there they they provided ratings on a 5-point Likert scale. From their ratings, the top 3 were selected. So now we have our 3 gesture set from the design study, and to the 2 techniques, our proposed RIARM and the baseline, which we will be calling ARM. We wanted to evaluate the performance of the gesture sets and the techniques, so we performed a user study. In the study, along with the 2 techniques and 3 gesture sets, we also included combinations of 2 distances and 5 different height changes as factors. The horizontal angle of appearance of the targets were chosen randomly with more details in the paper. This was a within-subject study with 12 participants, where 10 of them had prior VR experience. And development of this was done on the Unity engine with the Quest 2 headset, using the cameras on the headset itself and no exterior motion tracking. So each user performed a set of teleportations on each combination of gesture set and technique. The teleportation task included teleporting to semi-transparent spheres on a platform and providing the user a place to stand on after the teleportation. The targets appeared in varying and mixed combinations. So results from the user study showed that the users were significantly faster on RIARM, with the mean trial times being lower for the gesture set 3 and 4. And users' subjective evaluations show that they prefer RIARM significantly, also find it significantly easier. So to discuss some of our findings, we should say that we found that more flexible control over the teleportation pointer and its launch angle results in faster performance. So when designing hand-based teleportation techniques, researchers should consider providing users more flexible control. We also saw that some gesture sets were preferred more by the users than the others. These gesture sets, usually with high preference, were usually simpler and had smaller movements for the repeated actions. For example, confirmation is an action that you repeat again and again. So we suggest that you use, for repeated actions, designers or researchers should use smaller and simpler gestures. We also suggest using explicit gesture sets for confirmation and the other sub-activities instead of using a timeout or dwell, because it gives the user more active control and reduces the time taken for doing the teleportations. Researchers should also consult experts for choosing gestures, as we saw that the sets that were rated highly by designers were also rated better by the users. But our study has some limitations. Not all possible gestures were explored in our study. And for fatigue, because this is an hand-based movement, we only use self-reported qualitative measures instead of quantitative measures. And we did not test RIARM for a sitting environment. We did the test on a standing environment with the right arm only. So there are some limitations there. And we also did not consider any physical attribute differences between the users. So as a conclusion, I want to say that Using the combination of wrist and arm resulted in faster hand-based teleportation. And for complex interactions such as teleportation, where users have to perform different sub-activities, gesture sets can be used instead of timeouts or dwell. And also, future work can explore avenues such as personalization of user attributes and take them into consideration. So, for example, wrist flexibility and height for hand-based teleportation, as we saw that users with different flexibilities and heights were getting somewhat different experiences, so this needs to be explored more. And finally, I want to conclude that hand-based interactions are important in VR as users interact with objects as they would in the real world, like push, poke, touch, grab. But without locomotion, these interactions become limited to only nearby items. A complete hand-based locomotion system, such as WriArm, provides users with the freedom to explore both near and far interactions by moving around the environment without ever needing to pick up a controller at any point, opening up the exploration of new, innovative, and immersive hand interactions in virtual reality. Thank you.
Okay, so does anyone has any questions?
Hi, thank you for your presentation. My question mostly is about the confirmation and cancellation gestures. They seem that like users might mistakenly cancel instead of confirm, because it just, right, you have to, one is closing your fist and the other is just closing the index finger, correct?
Yeah, that's a very good question.
So do you have an error rate for that, or?
That's a very interesting question. So in the gesture set, we talk about cohesiveness. This is something we actually considered when picking, like, for example, I showed that there were many gesture sets, but we chose 3. But we found that being cohesive mattered more than being different. Like, if you used drastically different gestures for the set in the set, users would get confused and forget the gesture. So there is an opportunity to do something like, you know, how do the users remember these gestures, something like that. But what we actually found is that, like, cohesion mattered more. Like, if you make the gestures cohesive, users actually did not do like that kind of confusion a lot.
Okay, so any more questions? Okay, I have one. So one of the problems that you have on like teleportation type techniques is disorientation. Since you use like a more abstract virtual environment, did you actually thought about this? Did you measure that, or do you have any comments on this type of problem that could occur?
Okay, so I think we have some details in the paper, but I think we use the VRSQ, which has a question regarding this, the reorientation part. The thing is, like, we found the levels of reorientations to be same as the baseline, but I think, yeah, if we were to compare it to something like redirected walking or like actual walking, we would probably find that the previous work's results hold up, where like teleportation has reduced, I forgot what you just said, but
disorientation.
Yeah, increased disorientation. You're right on that.
Okay.
But like, I would like to add that, but even though there is disorientation, teleportation has many more advantages. So maybe it should be considered for like hand interactions when you're trying to make something else, but you need the locomotion system in there.
Okay. Well, let's thank again the speaker for the nice presentation.